Yo, 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 what's up, pre-calc? This is Mr. Taryn rocking with you again here. Today we're looking at 2.6 part 2, whereas part 1 was nonlinear inequalities. This is actually going to be rational inequalities. And when we say rational inequalities, a lot of the times we're going to have fractions, but fractions aren't a big deal. So let's get rocking. So your objective today is to solve rational inequalities. We just talked about that. Here are the steps. The first thing you want to do is you want to set your inequality equal to 0 and then simplify the rational as much as possible. A lot of the time you will have to find a common denominator because you're going to be adding and subtracting fractions. After we do that, we're going to set up a sign chart just like we did in the last video. But careful here, your sign chart, you're going to use zeros like you did last time, but also discontinuities, okay? So a lot of the times when you have like a vertical asymptote or you have a denominator and you can't have the denominator be 0. And then lastly, we're gonna describe our solution with our interval notation. So we got a couple examples here. We're just gonna rock through these real quick. Here we go. So the first example here, if you notice, my inequality is already greater than or equal to 0, so we can skip step 1, which is set it equal or set it equal to 0. What I need to do is I need to simplify this rational expression. So really, if you think about this, 3x plus 4 over x plus 2 minus 3, really this is 3 over 1, right? So I have to create, I have 3x plus 4 over x plus 2 minus 3 over 1. Now, in order to add or subtract fractions, we know that we have to have a common denominator. So I need to multiply this one by x plus 2. What I do to the bottom, I do to the top. And so now I'm going to distribute here. So I get 3x plus 4 over x plus 2 minus 3x plus 6 over x plus 2. Remember, you're subtracting this whole quantity, so I like to distribute the negative. So really this is 3x plus 4, and then minus 3x and minus 6 all over x plus 2. We're going to combine some like terms here. We have positive 3x and negative 3x. Those will cancel. I have positive 4 and negative 6. That's just negative 2. So we're at negative 2 over x plus 2 is greater than or equal to 0. So that's step 2. We've simplified our rational expression. Now we need to go ahead and create a sign chart. We need to create a sign chart here. Let's go green. And with our sign chart, remember, we're plotting zeros and discontinuities. Well, if you look at here, there are no zeros, right? But we do have a discontinuity at an x value of negative 2. Why do I say that? Well, if I plug in a negative 2 into my denominator, negative 2 plus 2 would be 0. Can't divide by 0. So now we need to use our sign chart. And if you remember from the last video, when you're plugging in to use your sign chart, always plug into the factored form. We don't really have a factored form here. All we have is kind of this idea right here. So that's what I'm going to do. I'm going to start plugging in for my factored form right now. So I need to choose a number to the left of negative 2. I'm just going to choose the number negative 3, and I'm going to plug in. So I'm going to plug in right here. First of all, I have a negative number on the top. I don't care what the value of this number is. I just know it's negative. And if I go negative 3 here, so negative 3 plus 2 would be negative 1. And so I have a negative over a negative, and we know that a negative divided by a negative is a positive. So now I'm going to test another number. I'm going to test the number 0 because it's super easy. So obviously the top of my fraction, if I plug in, is still going to be negative 2, which is a negative number. But then I have 0 plus 2 on the bottom, which is a positive number. And we know that a negative divided by a positive is a negative number. So there's my sign chart. I know to the left of negative 2 is positive. To the right of negative 2 is negative. My solution that I want is I want numbers that are greater than or equal to 0, aka positive numbers. So my solution set looks like it's going to be over here. So now to describe this in interval notation, all we'd write is, well, from negative infinity, oh, the bell. Oh, darn it. We're going to go negative infinity all the way up to -2, and we are going to put a bracket. And the reason why we're putting a bracket is because we said numbers that are greater than or equal to 0. So that would be the correct solution for this first question. Just basically on the domain, on the domain from negative infinity to -2, that's where my function is greater than or equal to 0. Not too bad, right? One more example. Here we roll. So same kind of thing as last time, except for this time, I'm going to have to go ahead and subtract the 3 first from both sides because I need to set it equal to 0. So now what I have is I have x squared minus x minus 11 all over x minus 2 minus 3 over 1 is less than or equal to 0. Same thing as before, I need a common denominator, so I'm going to multiply this side by x minus 2. What you do to the bottom, you do to the top. And so now I'm left with x squared minus x minus 11 over x minus 2. We're going to distribute here, so minus, and this is going to be 3x minus 6 over x minus 2. It's all less than or equal to 0. I like to distribute this negative. So then we're going to have x squared minus x minus 11 minus 3x plus 6 all over x minus 2 is less than or equal to 0. We're going to keep cruising up here. Let's go ahead and combine our like terms up here. So let's switch to blue. So I have a negative x here and a negative 3x. So that's going to be negative 4x. I have a negative 11 and a positive 6. So that's going to be a negative 5 over x minus 2 is less than or equal to 0. We're going to keep going. It looks like the top is going to factor this time. So it looks like that's going to be x minus 5 and x plus 1 over x minus 2. I like to put in parentheses, is less than or equal to 0. So now that we have our rational inequality factored, now I can go ahead and make that sign chart. I definitely want to keep this somewhere close by though, because when I plug in, I'm going to be plugging into that. So we're going to make a quick sign chart here. And remember, for your sign chart, both zeros and inequalities are graphed on this. So if I figure out my zeros here from the top, I have x minus 5 equals 0, x plus 1 equals 0. For my inequality, or my discontinuity rather, x minus 2 equals 0. I'm using zero product property for all of this. So x equals 5, x equals negative 1, x equals 2. Those three things are going to go on my sign chart. And 5. And now I need to just test points under each portion of my sign chart. So the first one I'm going to do, I'm going to test negative 2. And again, when we plug into your factored form. Otherwise, you're going to have a bad time. So here we go. So negative 2, if I plug it right in here, negative 2 minus 5 is negative 7. So that is a negative. Negative 2 plus 1 is a negative. And negative 2 minus 2 is also a negative. So if I think about this, a negative times a negative on the top is a positive. And we have a negative on the bottom. So I have a positive divided by a negative, which means it's going to be a negative. In here, in this part, I'm going to go ahead and test 0 because that's a super easy number to test. So 0 minus 5 is going to be a negative number. 0 plus 1 is a positive number. And 0 minus 2 is a negative number. A negative times a positive is a negative, and we have a negative on the bottom, and a negative over a negative is a positive. Now we're going to test another number. I'm going to test the number 3. So 3 minus 5 is -2, which is a negative number. 3 plus 1 is 4, which is a positive number. And 3 minus 2 is a positive number on the bottom. If I have a negative times a positive on the top, that is a negative over a positive, and a negative over a positive is a negative. And then if I were to test the number 6 out here, 6 minus 5 is a positive, 6 plus 1 is a positive, and 6 minus 2 is a positive. So that's just going to be a positive over a positive, which is positive. Now that I got my sign chart, I'm just about done. I want to look for solutions that are less than or equal to 0. So I'm probably going to use some brackets in here. And I'm looking for less than 0, which means negative. So I'm just going to scoot this up a little bit. So I'm looking where I have negatives, which is here and here. Those are my intervals where my function is negative. So I can say from negative infinity to -1 bracket. And again, the reason I'm using a bracket is because it's less than or equal to. And then again, from +2 to +5. That looks like it's the final solution. Again, I'm using brackets here because it's saying less than or equal to. These are my parts that are negative, so those are my solutions. That's all you got to do. The next slide, this is just some practice homework. But that's pretty much it for solving rational inequalities. Again, like I said, after every video, make sure you're reaching out to your teachers. If you have any questions, we will be glad to answer them. Well, that's all I got for this video. Have a wonderful rest of your day. Taryn out.